Are you smarter than an organic chemist?
Good evening, ladies and gentlemen, and welcome to our show, Are You Smarter Than an Organic Chemist? Tonight, we're going to dust off an old favorite, the Robinson Annulation. Now, let's go meet our contestants. Let's meet our first contestant. She hails from the Great North, and when she's not on the soccer field or playing with her dog, she is actively ignoring the Chem Group Me. It's Julia Keogh.
Hey Mom, hey Dad.
Our next contestant comes from North Andover, Massachusetts. When they're not in the lab or helping at the resource center, they're annoying professors in office hours. They're small, but they sure are feisty. It's Meg Quint.
See you at Friday, 1:30, Pelkey.
Your first question is, what is the first step of the Robinson Annulation? And draw the mechanistic arrows with the structures provided. It's your time to shine, Meg.
So, the first step of the Robinson annulation is a deprotonation of an alpha hydrogen. So, a D for deprotonation. So then, what happens is a base, such as an O-methyl minus in this case, or some other base can come and deprotonate this alpha hydrogen. That allows the electrons from the hydrogen to move and form a double bond, and then the electrons in the double bond for the carbonyl group to move up onto the oxygen to form an enolate.
Your next question is, what is the next step in the Robinson Annulation, and what is the name of that reaction? Draw the curved arrows on the structures provided. On to you, Julia.
The next step after the deprotonation is an addition, specifically a Michael addition. This is initiated by the lone pairs on the oxygen reforming the carbonyl, which then causes the double bond of the soft nucleophile to attack the alpha-beta unsaturated carbonyl. This then causes this double bond to move up here into a new position, which then reforms the enolate.
Next question is, what is the next steps in the Robinson Annulation, and what is it commonly known as? Describe and draw curved arrows on our structures provided. This is to take the lead, Julia.
The next step of this reaction is an enolate shuffle. An aldol reaction could occur with this intermediate. However, it would form an undesired four-membered ring. Instead, we want the desired six-membered ring, and therefore we have to use the electrons on this oxygen to reform the carbonyl, which will then form the alpha carbon to be reprotonated. In order to form the desired six-membered ring, there is a need for a deprotonation step. This alpha hydrogen gets deprotonated by a base, in this case, O-methyl minus. This hydrogen's electrons then get moved up onto this new position, which creates an enolate, seen here.
Your final question is, what is the name of the reaction involved in the final steps of the Robinson Annulation? Draw the curved arrows on the structures provided. It's all in your hands, Meg.
Well, thank you, John. The last part of the reaction contains an intermolecular aldol condensation. So what happens at this point is the enolate reforms a carbonyl. The electrons from the double bond can be moved and attack the carbon for the carbonyl, which allows this carbon right here, the alpha carbon, to form a bond with the carbon on the carbonyl, and the electrons from the carbonyl are moved onto the oxygen, creating an O-, which you can see right over here. So once that happens, the addition step, we can do a protonation. Specifically, the minus from the oxygen, the extra electrons, can steal a hydrogen from a base and form an alcohol, which we see in this next structure. At this point, we can do a deprotonation of this hydrogen right here because it is pretty darn acidic. So in this case, a base, specifically O-methyl minus, will take this hydrogen, allow the electrons from the hydrogen to form a double bond, and the electrons from the carbonyl to move on to the oxygen. So now comes our last step, the elimination step. E for elimination. The electrons on the carbonyl, on the oxygen, can reform the carbonyl, which allows the electrons in the double bond to move to a new spot and eliminate the alcohol, leaving us with the product of this Robinson annulation.
Now to our bonus round. This is the final question and the tiebreaker, a mechanism race. Quasinoids are polycyclic lactones that have been found to be antimalarial and anti-cancer drugs. Quasinoids can be derived from decolone A. This can be prepared from our beloved Robinson annulation. Please draw the mechanism. On your mark, get set, go. Julia has rang in. Meg, although she has finished, you should finish your mechanism as well. Julia, this is incorrect. You have lost a carbon at the enolate shuffle.
Done!
This is correct. You have won Are You Smarter Than an Organic Chemist, Meg? You've also won a $50 gift certificate to Katie's Chirality, an online store where you can buy chiral compounds. Congratulations!
Woo!
We'd like to take a moment to thank our sponsors, H2 Lindler, for being the answer that was never right, Katie's Chirality, for every chiral compound you could need under the sun, and Pelkey,